Hello, beautifuls. This is Atleen, and welcome back to my channel. So, Happy New Year. It's 2022. Can you believe it? Wow. Time goes by very fast. Well, I will be posting the CCNA 200-301 helpful videos every Tuesday and Thursday in 2022. So, if you like the content that I'm posting today and all through the sessions, please hit that like button as well as the subscribe, the notification button, so you see when I do upload. Alrighty, so let's move on. So today we will be discussing Vlsm as well as Flsm. First, we're going to go back and do a few questions on the Flsm. And Flsm stands for Fixed Length Subnet Mask. This means that all of the subnets use the same prefix length. For example, subnetting a Class C network into 4 subnets using like a /26. Vlsm, Variable Length Subnet Mask, is the process of creating subnets of different sizes to make your use of a network address more efficient. Vlsm is more complicated than Flsm, but is easy if you follow the steps correctly. So I will be going a bit slower than usual to ensure that you don't get overwhelmed. So today what we will be going over is the videos. In the video are two things. First, 200-301 CCNA exam, subnetting related questions. And lastly, we will go over Vlsm. Oh yes, and of course, I will give you in the very end more resources to go over the subnetting that we have already discussed in the last couple of videos. So this is going to be question 1. Once you have been granted the 172.30.0.0/16 network, we need 100 subnets with approximately 500 hosts per subnet. So what we need to find is the prefix length that we should use. So with this, we are asking ourselves, how many bits do we have to borrow to make 100 subnets? So we do this by using power of 2s as follows, looking at the screen. Borrowing 1 bit allows for 2 subnets. Borrowing 2 bits allows for 4 subnets. Borrowing 3 bits allows for 8 subnets. Borrowing 4 bits allows for 16 subnets. Borrowing 5 bits allows for 32 subnets. Borrowing 6 bits allows for 64 subnets. Borrowing 7 bits allows for 128 subnets. Borrowing 8 bits allows for 256 subnets. Borrowing 9 bits allows for 512 subnets. Borrowing 10 bits allows for 1024 subnets. And it would be great to write the borrowed bits and number of subnets down on maybe flashcards, because later we will see a higher number than 7, which is on the screen, 128. And the answer is 7 bits to borrow, which will give us the right amount of subnets. So borrowing 7 bits means we will use a /23 prefix length, which leaves 9 host bits. So again, the red bits are the host bits. So you write the 172.30.0.0 out in binary. And as you can see, we changed the host bits, which are in red. After the /23, as you can see, is 8, 8. 8 times 2, 16, 17, 18, 19, 20, 21, 22, 23. And then after that, after the /23, we will have all in red is the host bits, which is /23. So looking at the second part of the question, it states that we need 500 hosts per subnet. We go back to the borrowed bits and we use 2 raised to the power to the 9th power, which gives us 512. 9 host bits equals 2 raised to the 9th power equals 512. 9 host bits equals 2 to the 9th power minus 2, because you have to minus 2, one for the network and one for the direct broadcast addresses, which is way more than enough. 510 usable addresses. So borrowing 7 bits means we will use a /23 prefix length, which leaves 9 host bits. Remember, the red ones are the host bits. So /23 is written as 11111111 dot 11111111 dot 11111110 dot, and then there's 8 zeros. 255.255.254.0 in dotted decimal form. And please note, prefix lengths written in dotted decimal form, this would be on the CCNA 200-301 exam. So it would be good to understand it and learn it. Preferably flashcards would be good. Alrighty, so let's move on to question 2. What subnet does host 172.21.111.201/20 belong to? So we go back to the prior steps in the question 1 that we just did. Number 1, first, write down the address in binary. Second, change all of the host bits to 0. And remember, the host bits will always be in red. And then number 3 is to convert the address back to dotted decimal. So you can see that the subnet ID is 172.21.96.0. So host is 172.21.96.0/20. So let's move on to VLSM. VLSM is variable length subnet mask, which is the process of creating subnets of different sizes to make your use of network addresses more efficient. VLSM is a bit more complicated than FLSM, but it's really easy if you follow the steps correctly. So here is an example that we will go over of VLSM. And as you can see on the screen is a small example, which is an example of a small corporation enterprise network. There are 2 LANs in Tokyo and 2 LANs in Canada. So Tokyo's LAN A has 110 hosts, and Bangladesh and Tokyo, LAN-B, has 8 hosts. And as you can see, Canada, Toronto, Canada, LAN-A has 29 hosts, and Toronto, Canada's LAN-B has 45 hosts. Also, there is a point-to-point connection between the two routers that will assign IP addresses for, and we are assigned 192.168.1.0/24 network, and what we're going to do is divide it into 5 subnets to provide IP addresses for all hosts in the operating network. Tokyo LAN-A, Tokyo LAN-B, point-to-point connection, Toronto LAN-A, and Toronto, Canada LAN-B. Once we use Vlsm, variable length subnet mask, remember we're going to optimize. The keyword here is optimizing. We can assign different subnet sizes to each LAN, and this allows us to be certain each LAN has enough addresses available. So, what are the steps to subnet using Vlsm? Glad you asked. So, the Vlsm steps. Number 1, assign the largest subnet at the start of the address space. Number 2, assign the second largest subnet after it. Number 3, repeat the process until all subnets have been assigned. Once you look at the network, here is 110 hosts for Tokyo LAN-A. Tokyo LAN-B is 8 hosts. Toronto, Canada LAN-A is 29 hosts. Toronto, Canada LAN-B is 45 hosts. We will assign subnets in that order. First, we will go to Tokyo LAN-A, needs 110 hosts. And then Canada LAN-B, 45 hosts. Then Canada LAN-A needs 29 hosts. And then Tokyo LAN-B needs 8 hosts. Last, the point-to-point connection between the two routers. So let's do Tokyo LAN-A. Let's figure out the 5 listed here, the values placed with each network address, broadcast address, first usable address, last usable address, and total number of bits, number usable host addresses. And let's write the values of each. I will give you a few minutes to go ahead and see if you can fill those in. And the address we are using, 192.168.1.0/24. So I'll give you a moment. So we should decide to use a /25 prefix length. Why? Glad you asked. A /25 prefix length leaves 7 host bits, which means a total of 128 addresses, so 126 usable host addresses. And we require 110, so /25 is the correct prefix length. This means that the network address is 192.168.1.0/25. So we convert all host bits to 1, and this is the broadcast address, 192.168.1.127. The first usable address is the network address +1 and the broadcast address -1. So again, 7 host bits allows for 126 usable addresses, which is 2 to the power of 7 minus 2. So as you can see, the network address 192.168 192.1.0/25, and the broadcast address is 192.168.1.127/25. The first usable address is 192.168.1.1/25, and the last usable address is 192.168.1.126/25. Total number of usable host addresses is 126. So now we do have our first subnet. Next, we will do Canada LAN B, Toronto, Canada LAN B. So 192.168.1.127 is the broadcast address. And also the network address of Toronto, Canada LAN B is 192.168.1.128. The question now is, what prefix will we use for Canada, Toronto, Canada LAN B? So let's get that information. So to fit in with the 45 host, we will use a /26 prefix, /26 prefix, as you can see above. So here are the answers for Canada, Toronto, Canada LAN B. Network address is 192.168.1.128/26. Broadcast address is 192.168.1.191/126. First usable address is 192.168.1.129/26. The last usable address is 192.168.1.190/26, and the total number of usable host addresses is 62.